Ever wonder why you can't see around a corner, or why the word ambulance is written backwards on the front of the actual vehicle? Well, the answer to both questions is all about the fundamental and pretty surprising nature of light. So we're going to go on a little journey of discovery, one that starts with the moon and ends with your own reflection.
So, let's set the scene. Imagine a guy named Keshav who's on vacation, way out of the city. He's surrounded by fireflies lighting up the night under a huge glowing moon. And he starts asking these really simple questions. Questions that, it turns out, have some seriously profound answers about how our entire world works.
He looks up and asks the first big one. I mean, we all see the moon lighting up the night sky, right? But is it actually making its own light like a giant celestial light bulb? Or is something else going on? This is exactly where our investigation kicks off.
To figure that out, we need to get one basic rule of the universe down. When it comes to light, every single object falls into one of two camps. It either makes its own light or it doesn't. That's it. And that one difference is the key to everything.
Okay, so first you have your luminous objects. These are the universe's light makers. We're talking about the sun, a campfire, even those fireflies Keshav was watching. They all generate their own light. And right there, that gives us our answer. The moon is non-luminous. It's not making any light at all. It's basically just a giant, dusty mirror in the sky, reflecting the sun's light back down to us.
So that leads us to the next puzzle. You've seen it a million times. When car headlights cut through the dark, the beams look perfectly straight. We all kind of know this, it's intuitive, but how would you actually prove it? Well, it turns out there's a ridiculously simple way.
All you need is a candle and some kind of pipe. Yep, that's it. It sounds almost too easy, I know, but this little setup is an incredibly powerful way to show a core truth about how light moves through the universe.
First, you take a straight pipe and line it up with the candle flame. And, as you'd totally expect, you can see the flame perfectly. Of course you can. There's a direct, straight shot for the light to travel from the flame right through the pipe and into your eye. But now here's the crucial part. You bend the pipe just a little bit, and the flame instantly vanishes. Poof! It's gone. The light didn't bend to follow the curve. Its straight path was completely blocked. And that simple little trick proves the whole thing. And there you have it. Proof positive. Light travels in a straight line. Now, the fancy scientific name for this is rectilinear propagation, but all that really means is that light doesn't take detours. And that is the exact reason you can't see around a corner, which perfectly sets up our next idea.
Okay, so light travels in a straight line. Got it. But what happens when something gets in its way? Well, you get something we all see every single day. A shadow.
To really get what a shadow is, you first have to know how different materials handle light. Think of a clear window. That's transparent. Light zips right through. Then you have something like frosted glass. That's translucent. It lets some light pass, but it gets all scattered. And then you have a brick wall. That's opaque. Light hits it, and it's a full stop.
And that's exactly what a shadow is. It's not a thing itself, it's the absence of something. It's just an area, a patch of darkness, that's created when an opaque or translucent object gets in the way and blocks the light.
So, think of it like a recipe. To make any shadow, you always need the same 3 ingredients. Number 1, a light source, like the sun. Number 2, an opaque object to do the blocking. And number 3, you need a screen for that shadow to actually fall on, like the ground or a wall.
But just blocking light is only half the story. What happens when light hits an object that's opaque, but also shiny? It doesn't just stop, it bounces. And that brings us to the really cool science of reflection.
Reflection is just what we call this change in direction. When a beam of light hits a smooth, shiny surface, it bounces off in a new, totally predictable direction. This one principle is the whole secret behind how mirrors work.
You can see exactly what's going on here. The light is still traveling in those perfect straight lines we talked about, but the mirror, it's like a traffic cop for light beams. It doesn't stop the light, it just redirects it, changing its path completely.
And of course, this leads us to one of the most common ways we experience reflection, looking at ourselves in a mirror. But what exactly are we seeing, and why does it look the way it does?
Well, the image you see in a regular flat mirror follows some very specific rules. It's always the same size as you, and it's always upright, not upside down. And here's a fun fact. Scientists call it a virtual image. That just means it appears to be behind the mirror.
You couldn't, say, put a piece of paper back there and expect the image to show up on it.
But there's one more famous property, the one that always messes with people's heads. Why is it that when you raise your right hand, your reflection seems to raise its left hand? What's going on with that? Why does everything seem to be flipped?
This effect has a name. It's called lateral inversion. And here's the secret. The mirror isn't actually flipping things left to right. It's reversing the image front to back. The light from your nose bounces straight back, but the light from your right hand has to travel back to form what ends up being the left side of the image we perceive.
And this is the aha moment that brings it all home. That's why ambulance is written backwards. It's a brilliant, life-saving design that uses lateral inversion on purpose. They print it backwards so that when a driver looks in their rearview mirror, the word flips, and they can read it correctly, instantly. That's science in action, literally helping to save lives.
So think about it. We started with Keshav just wondering about the moon, and from that one question, we've proven light travels in straight lines, we've figured out how shadows work, and we've decoded the secrets of our own reflection. It just goes to show how simple curiosity can end up uncovering the basic rules of our reality.
I want to leave you with one final number, 8 minutes and 20 seconds. What could that possibly mean?
That is how long it takes for a beam of sunlight to travel from the sun all the way to Earth. That means the sunlight warming your face right now actually left the sun over 8 minutes ago. And here's the really mind-bending part. If the sun were to just vanish right this second, we wouldn't know. Our world would stay bright and completely normal for a full 8 minutes and 20 seconds before being plunged into total darkness. A final thought on the incredible but very finite speed of light.